We now discuss the solution of a problem from the section Integral Calculus. The problem is related to find the area of the given region. This question has appeared in the joint entrance examination main held on 6th April 2023 in the first shift. The given question is, if the area of the region denoted by S is equal to the set of all ordered pairs x comma y such that 2y minus y square less than or equal to x square less than or equal to 2y and x greater than or equal to y is equal to n plus 2 by n plus 1 minus pi by n minus 1, then the natural number n is equal to. We are given the region S, and it is given the area of this region S is given to be n plus 2 by n plus 1 minus pi by n minus 1, then required to find the value of the natural number n. We now discuss the solution of the problem in detail. We are given the region S. This is the region S. Now let's first of all see which curves are involved in the region S. So the first curve, call it as C1, that is 2y minus y square is equal to x square. Simplifying, you will get this as x square plus y minus 1 whole square is equal to 1. What is this? It is a circle with the center at 0, 1 and a radius 1. The center is denoted by C. The coordinates are 0, 1 and the radius r is equal to 1. Right. Now 2y minus y square less than or equal to x square is given. This will imply x square plus y minus 1 whole square is greater than or equal to 1. So this represents all those points that lie on the circle C1 and all those points which lie outside the circle. So it is the exterior of the circle. Outside the circle means exterior of the circle C1, including the points of C1. So this is the circle. So the points on the circle are included and the exterior. So this is a circle with center at C at 0, 1 and a radius 1. Agreed. That is the first one. The next one, C2, is x square is equal to 2y. That will imply y is equal to x square by 2. So what is this? It is a parabola. Y is equal to x square by 2 is a parabola with its vertex at the origin and opening upwards. So it is a parabola with its vertex at the origin and opening upwards. Agreed. Now it's given x square less than or equal to y. That means y is greater than or equal to x square by 2. So all those points that lie on the parabola and the points inside the parabola, this represents these things. That means the interior of the parabola and the points on the parabola. So the set of all. It is the interior of the parabola C2 and this is the parabola y is equal to x square by 2 with vertex at 0, 0 and opening upwards, and the interior is this one. The interior is the shaded one. Right. The third one is the line x is equal to y. X is equal to y. The line x is equal to y means y is equal to x. It is a straight line passing through the origin with the slope pi by 4. Right. So x greater than or equal to y means y less than or equal to x. will be what? The set of all those points that lie on the straight line y is equal to x, and all those points that lie below the line L. Below the line L. So this is the line passing through the origin with slope pi by 4. All points, so x greater than or equal to y, same as y less than or equal to x, contain all those points that lie on the straight line y is equal to x, and all those points that lie below this line L. This is the line L. Agreed. Now let's look at C1 and C2 together. So this is C1 outside the C1 and inside the C2. This portion. This is the shaded portion. This is the shaded portion. Right. And let's bring the line L also. The line L. So now the line L is also there. Now the common portion to these three regions is this region. This is the region. So I'll show you in the shaded region. So this is the shaded region, is the region, the S what we are talking about, whose area is to be found out. So we continue in the next slide, wherein we find out the points of intersection of the points. So right. So now this is the one what we have, right? So now first the circle C1 and the parabola C2, where do they intersect? The circles C1, parabola C2 intersect at the origin, that is 0, 0. The points of intersection of C1 means a circle and the line L are these 2 points. So what are they? So solve now. Solve. So this is the parabola equation, and x is equal to y, x square is equal to y square is the equation of the line. So solving, you'll get y into y minus 1 is equal to 0. That is y is equal to 0 and y is equal to 1. When y is 0, x is 0. When y is 1, x is 1, because it is on x is equal to y. So the points of intersection are 0, 0 and 1, 1. So the circle C1 and the line L intersect at 0, 0 and at a point B with coordinates 1, 1. This is the point B. Agreed. 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 Now the points of intersection of C2 and the line L. So these are the 2 points of intersection. So C2 means x square is equal to 2y, x square is equal to 2y is equal to 2x, because x is equal to y. So when you solve, this will be x into x minus 2. So x is equal to 0, x is equal to 2. When x is equal to 0, y is 0. When x is equal to 2, y is equal to 2. So the points of intersection are the origin 0, 0 and the point at 2, 2. That we call it as A. So this is the point A. This is the origin. Right. So that is what we have. The points of intersections are there. So the area to be computed we have already seen, but I will show you once again. So shown in the picture, this is the area. So this is the area to be computed. This is the area to be computed. That we will do in the next slide. Right. We have C1, C2, the line L, and the center of the circle 0, 1, radius r is equal to 1, A with coordinates 2, 2, B with coordinates 1, 1. Agreed. Agreed. So what we do now? So our task is to compute the area. This is the area to be computed. That's the area to be computed, right? So now drop a perpendicular from A onto the x-axis. Call it as AD. AD. Then A has coordinates 2, 2, perpendicular if we drop, D will have the coordinates 2, 0. So this is the one. Now how do we, now this is your D. Now the required area, this area, how do we get the required area? To compute the required area, what we do is compute the area of the triangle AOD or ADO, that is the right angle triangle, From that, you subtract the area under the parabola, this one, and subtract the area between the line and the circle, this one. Then you will get the area of this one. So the required area is equal to the area of the triangle AOD. From that, subtract the area under the parabola P. So the parabola, that area we denote it by P for convenience. And the area between the line and the circle, that we denote it by Q. So where is P? P is this, Q is this. This is the one. So now, let's first of all find the area of the triangle AOD. That is equal to half base OD into height AD is equal to 1 by 2 into OD is 2, AD is 2, 2 into 2. So that is 2. That is the area. So now let's compute P. What is P? P is the area under the parabola. So what's the parabola's equation? Y is equal to x square by 2. So the area will be integral x is equal to 0 to x is equal to 2 yp. That means the y of the parabola with respect to x. This is integral x is equal to 0 to 2. Y of the parabola is x square by 2 dx. And that will be equal to 1 by 2 after integration x cube by 3 to be evaluated from x is equal to 0 to 2. So when you take the upper limit, then you will get 1 by 2 into x cube, that is 2 cube, that is 8 by 3, that is 8 by 6, that is 4 by 3. Let's compute Q. Q is the area between the line and the circle. To compute that one, first compute the area of the quarter circle CBO, that is CBO, quarter circle. 1/4 of the circle. From that, subtract the area of this triangle CBO. So quarter circle CBO minus the area of the triangle CBO. So area of the quarter circle means 1/4 of pi r square. Pi into r. R is the radius of the circle is 1 square. So that will be equal to 1/4 of pi into 1 square. That is the area of the quarter circle minus area of the triangle. Triangle is half base CB into height CO. And that will be equal to, and CB is the radius, CO is also radius, and each is equal to 1. So this will be equal to pi by 4 minus 1 by 2. The area is equal to the area of the triangle AOD, that is 2 minus in brackets the area, the P plus Q. P is 4 by 3, Q is pi by 4 minus 1 by 2. So this is 2 minus 4 by 3 plus 1 by 2 will be 7 by 6 minus pi by 4. Now in the question, it is given the area is equal to n plus 2 by n plus 1 minus pi by n minus 1. So it's given the area is this one. But the area we have computed is this 7 by 6 minus pi by 4. They must be equal. So n plus 2 by n plus 1 is equal minus pi by n minus 1 is equal to 7 by 6 minus pi by 4. On comparison, n plus 2 by n plus 1 is 7 by 6 means n plus 1 is 6, n is equal to 5. And on comparison, pi by n minus 1 is pi by 4, that is n minus 1 is equal to 4, n is equal to 5. So in any manner. So on comparison, we will get the value of the natural number n to be 5. So the answer to this question is 5. So that is the detailed discussion of the solution of the problem, which is related to the area of the given region from the integral calculus. And it is definitely not an easy question, not a Not a very difficult question. It is something like difficult because it involves lots of calculations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.